The purpose of this experiment was to observe a system moving at the same speed without changing direction and to create a model analysis using Newton's second law to predict the system's velocity and position. In the analysis, in order to imply constant velocity, movement at the same speed without changing direction, I assumed the influences from my surroundings were negligible, or in other words, the net force is equal to 0. I observed the details of my own movement in tracker by setting the origin of my axis to the center of my back, here, with the positive y going upwards and the positive x going in the right direction. The center of mass being my own core area here, I then calibrated the length measurements to my height, which is 1.65 meters. The clip begins after I start walking in order to obtain an appropriate initial velocity and ends after 4.137 seconds. The clip also shows that I'm walking in the negative x direction. To analyze the constant velocity motion observed in the video, I created a computational model using Newton's second law, stating that the acceleration of an object is dependent upon the net force acting on the object and the mass of the object. New velocities and positions can be predicted inside the loop, here, with the new velocity predicted here each time the loop is run, and the new position predicted here. To create the constant velocity situation, F net must be set to a non-changing zero vector, which is indicated here. My mass was set to my actual mass, 57.833 kilograms, and the end time for the loop was set to the actual end time of the clip, 4.137 seconds. As I run the model, we can see that from the model created, the constant velocity motion was simulated. A graph was created to compare the model movement to my observed experimental movement with position in meters on the y-axis and time in seconds on the x-axis. The initial velocity, which I found from the observed video, was set to negative 0.879 meters per second at time equals 0. The model data, which is exhibited by this blue line, shows a perfectly straight line or constant relationship between position and time due to the constant velocity condition, also implying that the final velocity is negative 0.879 meters per second as well. The experimental line, indicated by these open red squares, shows a slight curve here, indicating a decreasing velocity from the initial velocity. This curve shows small human error, as while I was walking, I may have slowed down a bit in the beginning. Towards the end of the clip, though, a more constant velocity is apparent as the line becomes more straight. You may ask, how would the results differ or not if I change the axes? Well, if I flipped the x and y axes, my position would then change to y values, but none of the calculated values would change. Because net force is negligible due to the constant velocity situation, there's no definite way to determine the pushes and pulls on the system that equal the zero net force from the surroundings, although some forces assumed may be gravity as well as drag force. We may be able to investigate these missing pushes and pulls in future studies. But as seen here, the model is somewhat, or the experimental data is somewhat similar to the model data as we try to model constant velocity motion.